Hey, good afternoon, everybody. This is Professor Miller. It may be good evening or good morning. I am going to talk about auxiliary views, both in pictorials as in isometrics and also in orthogonal views. And so with that said here, this is theory lecture number 9, okay? And I'm going to zoom out here on the video a little bit. And that's zooming in, so that didn't work. And I'm going to go over a couple of problems here. First off, I want to look at this one. Okay, and so now I'm going to look at this problem, and what we have here is we have a view of the problem. Now, people get really stuck on what this could be. This could be a front view with a right side view. Okay, it could be a top view with a right side view. You know, you could turn it just about any direction. You could say now that you turn it this way. Zoom out a little bit. Again, wrong way here. Now you can say here that you have a front view with a top view, or over here you have a front view with a side view, and et cetera, et cetera. It really doesn't matter the orientation, but I'm going to keep it in the orientation that we have here. Okay? Now, how are we going to draw an isometric sketch of this first, okay, to show the inclined plane? Well, you have a block here that is so tall, that is so long. Again, here's my construction here. That's so far, if I call this the front view, or let's call this the front view here. So you have bottom, top, okay? You have left and right. So if I call that a front view, this would be a left side view. And then you have the very right hand end of the object and the left hand of the object. Excuse me, you'd have the very front of the object here and the very back of the object here. So again, you would have top, bottom, front towards back, okay? So now, again, front towards back here, left towards right here. I'm really kind of confused you. Left towards right. So let me just label this thing out to make it easier. This is the very front of the object. Excuse me, this is the front view of the very left side. This would be, make it a little bit darker. This would be the very right-hand side. This would be the top of the object. This would be the bottom of the object. Again, this would be the top of the object, the bottom of the object, okay? In this case, this would be the very front because it's close to the front view, and this would be the very back. So now, with that in mind, how do we orient this thing in space independent of the way the thing is shown here orthogonally? In an isometric sketch, so it shows the most detail. So with that said, I'm going to flip back and forth here, and I'm going to go to an isometric construction. Notice on this isometric construction that I have basically, I have it where basically I can go in here, and let's back off a little bit. And I've made a prism in which to draw this thing. And again, I'm going to call this the right hand end of the object. It goes back 18. It goes from bottom towards top 10. It goes front towards back 9. And again, to get this thing to fit over here, I count over from right here 10 full blocks to this point, okay? Then it went over 9, down 10, over 18, etc. Okay? So now I'm going to just show you this thing on a little bit smaller scale here than what we've had, so I don't have to keep flipping this thing back and forth here. And again, I'm trying to show you an orientation that basically gives you the best view of the object here. In other words, what can I do to basically give this thing its easiest view? So again, yours is oriented like this, okay? So now what I've done here is I've said, well, I'm going to orient it basically in a different direction. I'm putting what we have the inclined plane, this point down here. And I'm putting this point up here, okay? And then I'm going to draw then this part to the front, this part to the back. So again, I'm flipping this thing around, okay? Now if I was to actually go, I couldn't see through the paper, but it'd actually be like a reverse image of this thing. So again, if I was to sketch this thing in as a reverse image, let's see if I can do this overall here, and there, okay, and then there, and here, and then here, here, over to about right there, in, over, up, over here, and then you'd have this hidden feature going through it here, and a hidden feature going through it here. So that is what a reverse image of this thing looks like. Here's your inclined plane, here it is, and that's the way I'm going to sketch this, okay? That's the way I'm going to actually sketch this. So I know the overall values of this thing. So what do I need to do first? Well, the first thing I would put in here is I'd put the inclined plane in. Okay, I'd put the actually inclined plane in. And then from that distance, again, I'm going then 1, 2, 3, 4, 5, 6. From this side here over to here. So 1, 2, 3, 4, 5, 6. Count that right. 1, 2, 3, 4, 5, 6. I'm starting my development for my inclined plane here. Okay. And that plane then goes from the front, from this point here, from that point there, all the way down to the bottom. And I'm on the very front of this object. So I'm going to cheat here a second. And I am going to use a straight edge just for a rough construction. Now when I go over this, it is going to be done then with pen. So from there down to there, and then from here over to right, if I can get this over here then, right there. Okay. So now, my inclined plane, which I will put in this purplish color right in here, goes from here down to here. I'm on the very front, at the very top, going on the very back of the object, coming all the way down, then front towards back. So now I know where the inclined plane is. I've got the inclined plane shown on here. Now we need to know, okay, the way I drew it, this notch here is on the very front of the object. And know it comes down 2 from the top, okay? And again, if I would go and turn it this way, this distance right here is 2. The bottom's 2, okay? So this is on the very front of the object. So if I come up from the bottom, up 2, bring this over, it'll go until it hits the inclined plane at this spot right here. And then it's 2 down from the top. It's going to come over and hit the inclined plane right at this spot right here. Now notice, observe these points right here. These points are not on a grid line. They are not on a grid line, okay? And again, then, that thing goes from this front of the object back in here too. So then from the front of the object here, it goes back in too. So again, I project this thing out over into here somewhere. I just kind of let it stop right in here. Okay, so again, if I was to take this all the way out to the end, it would go up 2 and over 2. Again, so if I come to the very front of this thing, it would go up 2 and over 2, and would find this point. And then if I went to the very back, so I'm going to then locate the very back corner of this thing. So this is why you need your construction box in here. So go up 2 and over 2, and it would come all the way back from here to right over into there, excuse me, to right, I might get the right location here, it would go up 2 and over 2, let me see here, over 2 and up 2, okay, that's right, it just goes to there and it stops, okay? But now, okay, now, we've also now, so we've got to basically show where this cutout here hits the incline, so we know that this point, which I will label A, is right here. Again, mine's reversed in the way it's oriented, but it doesn't matter. This is B. It's on the very front of the object. Here's B right here. And then we know that that thing has to go in 2 blocks. So we can count this way over 1, 2 blocks. And we also know that this line here, that line there, that line, that line, that line, and that line are all parallel. So if we know that A is right at this point, we can come back over here, okay? And then B is right over here, we can come back over to here, okay? So again, if we bring that back, now we also know that each of those line segments are parallel also there. So then I can connect, let's call that point C and point D. So now I can connect in C back down to D. So connecting C down to D, and I've got this part of the object shown. Okay, well let's draw this in here, and then I'm going to darken in some things here so you can actually visualize what I've done here. Okay, so I know that I have basically the top part of the object is not touched, so I can go across here, darken that in. I can go across here and darken that in. Oops, that's a really bad line right there. Darken this in here. Darken in this here. Okay. Now for this notch out right in here, I can then go down, bring this over until it hits the inclined plane at my construction line. Bring this down. Bring this over. Again, these are parallel. Bringing this down to here. Bringing that over. Again, parallelism there. The notch out is here. The notch out's over here. Again, bringing this forward here. A little bit off there. Bringing this down. Bringing this then forward. Bringing this down, and then bringing this forward here. Okay? The bottom of the object here, the bottom of the object, let me turn this thing here so you can see what I've got so far. This bottom here goes straight across, so that's not touched. Okay, so we've got that part of the object in. Now what we have to do is pretty much the same thing here. We've then got to cut out this notch right in here. So again, that notch comes up 1, 2, 3, 4 is 2, or 4 from the bottom, then is 2. So again, I'm going to stay right on this front part. It comes up 1, 2, 3, 4. Here's the notch right in here. If you take that back, it touches the isometric plane about right here. And then again, 1, 2, 3, 4. Let's see here, 1, 2, 3, 4. I better watch what I'm doing. I'm not real accurate there. Let me correct this. So again, 1, 2, 3, 4. Okay, it starts to go back here. It goes back in here. So again, it hits the inclined plane. Wherever it touches at, it goes right back and hits there. It goes right back and touches it there. Okay, well then we know that if the notch was over here on the very top, then we can this line here goes straight back parallel. And then this one goes straight back parallel. Okay, now some of these we'll see and some of them we won't. But now we know, oh, here we have this then shown right in here. We have that part shown right in here. Okay. Again, now notice that this line are parallel. Okay. And then this line and the line over here will be parallel. This line here, okay, will be parallel. So again, if you count over again from, we go over 2 back to here, okay, and let me see here. This is going to come parallel down to right in here. Another way would be to come over here, and to make sure you get this right, 2 blocks here, and then over 2 blocks, and draw then this straight construction line in here. And notice I was pretty accurate there. Okay, I was pretty accurate. So that comes over. Then this bottom part is parallel here. So again, there's the cutout on the inclined plane. So I can drop this down. I can bring this over. I can bring this over. I can drop this down. I can drop this down. Okay? But now I have to show the distance going from the right hand towards the left hand, so don't forget to put your depth line in there. Okay, so again, there's the construction of that piece of geometry from this. Now notice I oriented it so I get the most descriptive view. Remember, these orthogonal views are just there to show things. Okay, this is but that doesn't mean on an isometric that's going to be the exact way that you're going to construct it. So be flexible with these. Think about what you want to show first. Okay, box in the entire overall size. Put in the inclined plane. Put in any cutouts on the normal surface at this left end here and at the front end here, and project those points back to the inclined plane, realizing that this and this, that have to be parallel, and this line and that line segment, 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 they all have to be parallel. Okay, so now you're showing that thing done as an isometric, showing an inclined plane and isometric. So you build the construction geometry, build things on the correct faces, and then shoot them back or bring them forward to the inclined plane, whichever is most appropriate. Now let's get into an orthogonal view. Now an auxiliary view on these are really to show, in this case, a true size and shape representation of, in this case, an inclined plane. So now what you want to do is you want to find where the inclined plane appears as an edge. Okay, well, this goes parallel, that goes parallel, so it's going to be the plane here. Okay, it's going to be this plane here. Notice this plane all the way goes from the top towards the bottom. Okay, so its general inclination is top towards bottom, okay, and front towards back. Okay, so now this is the top of the object, this is the bottom of the object. Okay, this is the left end of the object, closest to the left view. This is the right end of the object away from the view. So when you basically go and describe an auxiliary view, you're looking for the dimension that is not in this view. So I know top, I know bottom. In this case, I know back and I know front. So in this case, I don't know my left from my right. Okay. Now, a critical part is, in order to get a view of a plane, you have to be able to view the plane, or your vantage point, or your viewpoint from the plane has to be normal or perpendicular. So we find one where the plane appears as an edge. So I'm going to write these steps out. 1. Find incline plane as an edge. 2. Your line of sight, which is LOS, line of sight has to be perpendicular to the inclined plane. Now, before you do all this, you want to make sure you set these things up so you have plenty of room to draw the inclined plane. So if you notice here, I started at the very close to the left-hand side. It's 1 block over, and I brought this one over like 6 or 5 blocks from the side. Okay, so I need a lot of room to be able to put this inclined plane on. So here's the inclined plane right in here, and I'm going to label this inclined plane. I'm going to name this inclined plane A. Let's not do, yeah, let's go A, B, C, D, E, F, G, H, I, J, and K. So line segment AB is 1, BC is 2, CD is 3, DE is 4, EM is 5, MF is 6, FG is 7, GH is 8, HI is 9, IJ is 10 and JK is 11. It has 11 line segments or sides that make up that plane. So wherever that plane appears is going to have 11 sides to it. It's going to have the same general shape. So let's label these points in this view. So this in this view is going to be in front of B. So A, point AB signifies going from left to right, line segment AB. This is KJ. Okay, this one is DC. This one is EM. This one is HI. Well, hello there. And this one is then GF. So I've got the planes labeled or the points, the vertices labeled in both views. Okay? So again, make sure you leave yourself plenty of room. Then you're going to draw projection lines from the inclined plane that are perpendicular. And they have to be perpendicular. There's no shortcuts on this. So this one time a straight edge, again, will come in handy. So I'm just coming over here and I'm drawing these lines with a straight edge, which in my case, I'm just using an index card. You know, make it so it's laying up against here. And again, accuracy. Some of your sketches I've seen have been very, very beautiful, and others, you guys look like you're back in the Stone Ages drawing on the walls, being blind in one eye and can't see out the other. In other words, you need to take time and make these sketches nice and neat. They're a reflection of you. You draw sloppy sketches, people think you're sloppy, and you don't want people to think of you as being sloppy. So again, I'm turning it over here for convenience, projecting this out. I'm projecting out a long ways here, projecting it out over here. Okay, so then my next step is to then, step 3 is to construct perpendicular lines. Okay, the lines I just put on here, again, from every intersection of a feature on an inclined edge. Then the next step is to start, in this case, remember, this is left, this is right. So we want to put the very left side of the object somewhere over here. Now that view of that line, those line segments, AK, HG, is going to be on the very left-hand side of the object. And notice that they are parallel with each other and they are perpendicular line of sight. So they have to be parallel with each other and perpendicular line of sight. So what I'm doing is I'm picking, and I'm going out here, just this distance here is arbitrary. So I'm just picking a distance so far away. The distance here does not matter. It does not matter, okay? I'm putting a construction on there at this distance. Let me make it a little bit darker here so maybe you can see it better. So I'm going to go over here, make that a little darker. And again, let's make these lines here a little bit darker, these perpendicular lines here so you can see them. Okay, there. And then here. Move this up a little bit. Here. In drawing 5, you know, if you don't like to sketch, you know, people, why do I need to do this? Well, why don't you ask your people at Boeing and McDonnell Douglas and GM and even the smaller businesses. You have to be able to convey your ideas graphically. And there may be at some point in time where you may have to sketch an auxiliary view out quickly. Okay, so now I've got those constructions. This line here is 90 degrees. These are 90 degrees. There are no shortcuts. They have to be perpendicular. Okay, so now we know this is the top. We know this is the bottom. This is the back, and this is the front. This is the way I label them. So the missing view from here is going to be left to right. Okay, so now I said right here is the very left end of the object. Okay, a little bit left out in here. So now what line segments are on the left end? A, K. So here's point I'm going to put this darker so you can see it. Here is point A. Here is point K. So then A connects to K. Okay, what other line segments out on the front here? H and G. Well, projecting out. Here is H. There. Here's G. Right there. H connects to G. Now let's just step our way back in. We go in 2 blocks. Well, then now you're measuring from left towards right. Okay, well, how do you measure 2 blocks here? Well, just use your handy dandy piece of scrap paper. And I'm going then from left towards right 2 blocks. So I'm just lining the front of the sand going back 2 blocks. So then that's going to be at point J. Well, K and J connect together. Okay, so then right in here, this is going to be point J. And then H and I connect together. So then right over here is going to be point I. Get this marked a little bit better. Again, I'm just taking a piece of paper, I'm measuring. You don't need to get out a ruler or anything. You've got a handy measuring instrument here. So now you know that K goes back to J. K goes back to J. H goes to I. And then I and J connect. So this is I. This is J. So now let's work our way back even further. Okay? Well, let's go to the very right of the object here. A goes clear back to B. So I'm going to say, well, here's my A, and this is the distance from left towards right. So here's B. So then A goes back to B. So then right here is point B. And then G goes back to F. So then right here is point F. Okay, so A connects to B right here. This is going from left towards right. And then G connects back to F. So then this is point F right here, point B right there. So then B connects to C. C's on the very back of the object. Well, where is C at, okay? Okay, so then how do we find C? We project C over to here, project C down to here, and then we have to measure that, which is, again, 2 units. So I find where C is. Now, what I'm going to do here is I'm going to put a like construction over here, give a reference from the back of the object. So again, I'm coming over here, bringing this across, and then C is going to be on this line, so then here is point C. And then C connects up to D. Okay, let me see here, excuse me. M connects to E. Okay, so M's on the very, stop here a minute, I'm messing up. C's on the very back of the object, here is C. M's on the very back of the object, M comes here, there is M. C connects to D. So then now this point becomes D. D connects down to E, which is behind M. So then M goes back to E. So now we have B from over here going to C, B going to C, C going back to D, C going back to D, D going to E, D going to E, E going to M, E going to M, and M going back down to F. So again, point D, C, E, M, and F. And there is the inclined plane shown true size and shape. Its distance from here is equal to this distance here. This distance here is equal to the distance here, so on. It starts here, it goes clear over to there, so that gives you the total distance of the incline itself. How many sides did it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like we said, how many did I say before? 12 maybe? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it better have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Same general shape as this, yes, that's how you do an inclined surface, okay? So after we constructed the lines, you know, we locate points. And really, for all intents and purposes, is like elementary school, connect the points. And that is how you work it that way. Okay, so let me zoom up on this so you can get an idea of what I'm saying here. Okay, there's those notes right there. You know, find the plane as inclined, plane as an edge. Locate your line of sight perpendicular to the inclined plane. Okay, here's our plane as an edge. Right here is our line of sight. Okay, construct the perpendicular lines here. Locate the points from the given view, and then connect the points together. And there is a close-up of the inclined plane. Back out a little bit. And then there is the view of it here. And then over here again, showing you what it looks like from an isometric standpoint. Notice how nice and neat, except for things like this thing should be. I've noticed a couple of these things, like I said, they're just drawn really, really sloppy. I'll have you do them over, okay? So that's the first one, okay? Hopefully that's going to help you some. So that's the first one. So now let's trek onward here, and let's do another one here, okay? The other one is, let me zoom out just a little bit. Okay, you have then basically, let's call this a front view and a left side view again. Okay, so again, I'm going to label this thing, excuse me, top, bottom, if that's a front view. This has got to be your left, this has got to be your right. Okay, so you can make these in ink here so you can see them. Top, bottom, left, right. Well, if this is then going to be the top over here, and then the bottom over here. That's top and bottom, then this becomes what? Well, if this is left and right here, then this is going to be the front of the object. Say front right here, and this is going to be then the back of the object. So again, your missing dimension is this view, left to right. Find the plane where it appears as an edge, right in here. Okay, so we're going to come over here, and I'm going to then draw all my perpendiculars from that plane. So again, here, I'm going to draw a perpendicular line here. Yours should be lighter because yours should be construction, but I have to make mine at least dark enough that you can see them. Here, there. Okay, I'm going to go ahead and put this axis line on here. So I'm going to put this as a construction axis line, just so I know what it is. So notice I put that in there, just to help me keep things straight here. Again, another dashed line representing hidden features. And then I'm going to come over here and turn it around a little bit. Project over to here. Project this one off down to here. And then project this one over to right here. So now, again, these are all 90 degrees. You cannot go by grid points. It's just wherever they fall at 90 degrees. So now I'm going to draw my construction in here. So this is now I got to find, in this case here, I'm going to find the very left-hand end of the object. So again, I'm coming off of here at some random distance. And again, notice keep these views apart from each other. So you have plenty of room to draw this thing, okay? You sure would. You could actually draw it in the, from this way going down, but you couldn't fit it on the page. You don't want your views to overlap. You got plenty of paper, so use it. So I'm going to come over here and say, okay, about right in here. Pull out here a little bit further than the last one. Here is going to be then the front, the left-hand end of the object right here. And going back then this distance, so let me get a new measure side here. So I'm going to go over here and say, well, while I'm here, I'm going to put a point there, a point here, and a point there. So this is the very front of the object. This is the very back of the object. So again, this then would become your very front of your object. This becomes the back, front of the object, and then back in here. And again, then when you're done, if you do this accurately for a sketch, these should all be parallel, the projection lines, and this should be parallel. So now we know that if you don't know anything else, that you basically, here's my very left-hand end of the object right in here. Here's the very right-hand end of the object. I might have said front and back earlier. Okay, so again, this is my left end. This is my right end. Because again, left is closer to this view than right. Okay, because this is a left side view. So now, let's study this thing here a minute. Okay, let's go ahead and just study this particular, where we're going to get our measurements from. Now, so what do we have here? Okay, what do we have? We have a partial positive cylinder here that you can see constructed in. We have a negative cylinder here. We have then a partial positive cylinder here, a partial positive cylinder there, and a negative cylinder there. Okay? So now what we need to do is to actually locate each of these different features on there. So now I'm going to basically darken in some of, here's my original construction line, here to there. Here's my construction line, there to there. Okay? And again, there was my construction box when I drew the circles. Yes, you should put those on there. Yes, it makes you draw better sketches. So now, I'm going to start, I'm going to label this particular object here. Okay, I'm going to label this point A, B, C, D, E, F, G, H, I, J, K, L, and M. Okay, so I've labeled each of those points on that particular view. And then I'm going to label each of those points on my auxiliary views. So I'm going to circle this as left, this is right, this is the bottom, this is the top, this is the front of the object generally here, this is the top. Okay, let me get over here so you can see what I'm doing. This is the bottom, and that's the back. Okay, so now, back out a little bit. Now I want to transfer those points onto the auxiliary view. Well, before that, I'm going to bring those points over on the inclined plane. Okay, point E is the very top, so here's point E. The next point down is going to be D and then F, and they're both on the axis. So then right in here is point D, comma F. D generally in front of F. Okay? I'm skipping the actual negative geometry now. I'm going to prove all the positive geometry first. Okay? Well, then I have line segment BCGH. So that's right in here. That's B, line segment B, comma C, and then I can find segment G, comma, H. And then right from here over is the basically hidden feature that's called line segment L, comma, M, which is right there. And on the bottom we have line segment AM, JI. So this one here at the bottom is A, comma, M, and then J, comma, I. So now I have all these points transposed into this view. So let me zoom up on here a second and show you these points. Again, if you're doing yours, E's at the top, DF is at as the axis. I'm skipping the hidden geometry. Right down here where it's kind of stair step, it's line segment BC and GH. Again, the hidden geometry here, rectangular prism is LM, and at the very bottom is A to M, and then the negative prism, and then JI. Okay, so those are our points. So let me see how close I can get. It's about as close as I can get. So now what's on the very left hand end of the object? Point A and B. Okay, point A and B is on the very, very front of the object. Well, right here's A, so this point here becomes A. Here's B, so this point becomes B. So A connects to B. So I'm going to go ahead and connect A to B. Okay, then B connects back to C. Well, then here's C. So then I have to take that measure from this view. And remember a little bit ago, I went over here and I said, well, this is the front of the object. Let me zoom up on this. Zoom up a little bit more. So I'm going to circle my front and my back on here so it's less confusing. Hold that thing into place there. So here's the this is the left end of the object, the right hand end of the object. I did say front and back earlier. Here's the left, here's the right. Here's point I, and above it H, J, M, and A. So now on this one, we're going from B towards C. Well, C is directly above, or C is directly to the right of B. So here's right. So again, I'm going to come over here and say, okay, constructing this thing in, right here is going to be point C. B, okay, let me zoom back out. So what I did is I took that value right here, which M and C at the same point, and I measured it back from over here. Because again, if I just bring this up, C is right there is the same as M. Okay, so then what do we have happening? Well, point B here and then connects to C. Now what happens on the back? Okay, let's look at this thing from the back. On the back, you have point I, and you also have point H. Well, then right here becomes point, let me move this over. Right here becomes point I, and then directly across from BC is line segment GH. Okay, well, H is on the very back. Let me scoot this down some. So then this becomes point H. H then is, if we come back over to here, again using my handy dandy instrument here, measuring instrument, okay, H is here. And then G is directly to the left of H, that same distance. So here is H. And then this point here becomes G. Let me move it so it's all pointing to the bottom. Point G. And we know then that I connects to H connects back to G. I connects to H connects back to G. Okay, so now we want to define then the rest of the prism. Okay, the rest of the prism. Well, if we imagine this, a prism is right in here. So if I imagine a prism right in here, I'm going to develop the prism. So then we've got point C and G defined. So now we just need to point D back to F, back to G to define a prism as a construction. Okay, so we have C. Well, here's D right over here, and it's directly in this direction, because if you notice right on here, okay, they're the same distance from left towards right, and this one's the same distance from right towards left. So if we come over here, here's get this on here again. So then here is D and F. So then I have C coming back up here, and in G coming back here. Make this a little bit straighter. You should be parallel, and then this becomes line segment then D, construction line segment F. Okay, well now we know that over here that D connects back to C and that G connects back to F. So C connects back to D and G connects to F. Okay, so I'm going to put then line segment D here and F there. Now, let's go to the bottom of the object. Let's look down in here, because I'm going to stay away from that cylinder for a minute. Okay? Now, we want to find, again, if you imagine here, a rectangular prism right in here it would be L, M, J, K, L. Okay? Well, M is directly, and L are directly 2 units to the right of L. J, K are below G, which are 2 units to the left of HI. So we already have these points. So we know now on the bottom, so if we come over here, we know that we have point C. They're all coplanar here. So now if you come over and do a sketch line from here out, and a sketch line from here out, we can label these points. So again, L will fall right here. There, okay. M is right here. Here's A. This one is J, right there. And then this one over here is M. So again, I projected. Let's see if I can get this. Let me back out a little bit. So I projected L back, M back, and excuse me, I messed up. That should be K right here. Here's L, and this should be K. Okay? So now if we look over here, J connects to K, connects to L, and L to M. So we're not going to build in the whole thing. We're just going to build in there, to there, to there, to here, to there. Now we have the bottom part drawn, constructed. Now let's go and let's look at the positive cylinder here, the positive cylinder. So I'm going to add some points onto the positive cylinder. I think my last point was M. So I'm going to add a point right here that's called N. And I'm going to add another point on here that's called O. Okay? So now, what we have to do is measure these points from down from E. So let's, again, E then, if we look at from D to F, we know that E projects straight along here, and it's going to be halfway between here. So what I'm going to do is I'm going to go ahead and light construct this right in here. So again, I'm coming over here, it's construction, and then here then is a construction, basically prism for an ellipse, okay? So now we know that point E is right in the middle of this whole thing. Okay, so I'm going to move over to my view right here, and again with my handy dandy instrument, I'm going to say that right here is point E. Okay, so coming over here, E projects off of here, and it falls then right here, point E. Okay. So then E is a construction line here. So it's a construction axis. So I'm going to draw it as a construction axis out here. Okay, let me draw it in darker. There's construction axis. Line of symmetry. Okay, divides that thing right in half. Okay, so now what we need to find is some more points. So we can then plot points. Well, we put points in right here and O right here. So what we need to do is project those points back over to this line. Now notice we also have what point? We have D and F already shown on here. We have D and F shown here, and we have D and F here. So what I'm doing is I know that this thing has got to go and curve around from D through M to E through O back to F. Well, we have D and F and E already here, so I'm just going to put a couple middle points in here. So what I'm going to do is project, come back out, and then I'm going to project over from N and O, which again, it's the same spot right over here. They're right on this. I'm lucky, and I got them fitting right on this line right in here. So again, then right over here, I projected. Let me get on a side here that's straight here. So I've got the line right in here. So then N is generally to the left of O. So then this point right here becomes N, comma, O. Okay, so what I did, zoom back in here. I put this point 45 degrees here, N and O, they happen to fall on that line, and I projected them over at the inclined plane right here. Then I project N and O up. So N and O are going to fall along this projection line right in here. But now we need to find a distance from where they're at. So I'm going to basically say this is E right here, that point right there. Okay, a little bit more accurate. So now I need to know where these points are from left towards right. Well, I can measure this distance right here, because I know right here is the axis, which is on E, which over here is E. I know they're going to be projected off this line here, so I can measure from the left towards the right that same distance. So again, coming over here, I'm going to then measure from that distance right over here. And let me see here, get one that's a little bit clearer here. I'm going, and it's just from about right there over. So here's O, and the same distance and about right in here. So that's N, and clear over here is O. So again, N and O project over to here. They project up to here. N is to the left of O. Here's left. Here's right. Here's N over here. So I lay this thing on here, so then this is point E, or the axis where E is at. So then right over here, this becomes then point N. And this point over here becomes point O. So now I can come over here and say, okay, D comes through E, E comes through O, and the more points you put in here, the more accurate this thing's going to be. Okay? I mean, you could put another couple points in here. I'm not going to do that now, but again, it is an elliptical shape. Okay, if you look at a cylinder, any other angle besides that, it's going to appear elliptical. So I'm going to come over here and say, okay, let's go ahead and grab this thing right in here. Okay? Now we got this spaceship taking off here. So again, you've got the, let's put a little fire coming out of the bottom of it here. So you get the spaceship taking off here. Okay, going in that direction. But now what do we have? We have to place the hole in here. Well, the hole, again, shouldn't be that difficult, because now, if you want to, we can keep naming it. O, let's name this point P, this point Q, this point R, okay, this point S, And we could put more points in there, but we know that point P, so if we project P over, it's also here, and it's between N and O. So that's NO and then PO. NOPO, okay? And we know that P is right on the axis, so then this point right here becomes P. Well, there's P, again, P projected over to the incline up to here, it's in the middle of the object. So we also know then where point R is. R is here. R then is projected over. Okay, here's then R. R goes up, and it's also where? Okay, in the middle of the object. So this becomes R. Okay, I'm going to see what happens here pretty quickly. Okay, now we know O and S. Well, O and S are about one block in. So again, I'm coming over to this view right in here, and I'm measuring this distance right here. It's from the right towards the left. So now I know R is here. So if I just measure a distance here, another distance here, a distance, if this thing was, so that gives you then at basically at the top, you can have the same. Now this is, let me go through this again here so I don't, so again I found then the distance S and O, excuse me, so S and O comes over to where? S and O is between D and F, okay, so it goes DS, OF, okay, so then if I project S and O over, so in between these two, let me bring this up and do this again. So what I did here again is I went and I found point O and S, projected those over to here, so then S is generally right to the left of O, so then this point right in here becomes S, comma O, so then they project up to here, okay, and again I measured these distances from right there over, same thing there. So if I follow them over to where S and O is, then I can say, okay, here is that construction, or that exactly construction point right here, and then over to then here. And then if we put a construction ellipse box in here, okay, there is what would contain the ellipse. And then the ellipse now, again, what you'd want to do is do a series of points here. So I'm going to then unlabel it. I'm going to grab this point right here. So let me zoom up on this point here. So I'm grabbing this point, which is directly in front of this one. I'm projecting that point over to right about there. And I'm projecting that point up across here, and then that point is measuring whatever you want to name that point, that distance from, moving this over, that distance from here. So again, I projected that point over, found it, projected it up, across here, measured that distance from the center point, which is the same as there to there. So again, there's my projection. I probably benefit you to label it, but then there's a point right here. There's another point right there. And then you would know that the same series of points on the bottom end would be the same distance away. So I'd come over here and project then this point to about right there. Project that point up to that view. And then you have another point there and there. And again, so then you can start to construct the ellipse. So let me get over here. And so then I'm going to go right into here, right into there, right around here, right around there, right around there. Trying to make this a little bit more accurate. Then darkening it in. This end here looks pretty good. There's my ellipse. Same general shape as over here. Same amount of sides. So what do we need to add in here? Well, we still need to give this axis in here. So we're coming across here. Since this is a symmetrical part, I'm going to bring this axis and split the lines up and bring it all the way through the part. And there will be a representation of that view. Let me zoom back out here so you can see what the whole thing looks like from there to there. And that's pretty much how you define, you know, inclined planes on drawings. The reason why you do this is now you can put measurements on here, dimensions on here. You actually can measure these dimensions on here. So that's the reason why you draw these. These things are true size and shapes. I can say, oh, over here, if I want to put a dimension, then, you know, this is whatever it is, whatever size that is. Okay? And so on. Okay? So any questions? You know, hopefully this has helped you some. Here's points B and C right there. You know, it's just through a matter of projections there, and that's how you end up doing these particular types of auxiliaries. Okay? That's how you do the auxiliaries. Now, the fun part is, let's do the auxiliary on here. Now, if you look in here, what I started with is I'm going to darken some of this thing in, but again, I came over here and I sketched in the full construction, and then I cut things out. So I cut this out of the block. Cut this out. Cut this out. And you're going to see a shape here appear. You want to do things in stages. Okay, bringing this up, bringing this over, you know, bringing this all the way across the top. Bringing this down. Again, bringing this over. And again, it might help you to use colored pencils to construct this over this cutout here, and then this over to here. So I cut that portion of the object out right there. Okay? Let's finish it off here, finish it off right in here. And then I went over, oops, I got a little carried away there. Let me get rid of this. That's why you do it in construction first. Then I cut this out here, and here, and there. So what I started out with was a big prismatic feature. I cut out a negative prism on the front, I cut out a negative prism on the back, and I cut out then this negative prism right there from this end over. So now what I'm going to do is I'm actually going to go through here and I'm going to put the inclined plane on here. Okay, I'm going to go ahead and put the inclined plane. Well, the inclined plane, if you remember on this one, it goes from right here all the way up to here. Okay, so again, if you notice in here, I basically went through here and I laid that out. Again, construction-wise here. There. To there. Again, on my very outside construction. And then from here down to there. Okay? So then there is that inclined plane as construction. Okay, well then I know that inclined plane is this part of it's removed. So again, I'm just going to put the rectangular feature in here again. So again, notice that over here that this line, which is my construction on the outside, and that and that and this and that, and all those are parallel, and they're this far in from the left going towards the right, which is 2 blocks. So again, if I come over here too, then I can say, okay, right in here is I'm going to put another construction line parallel to these into from left towards right, which is what I defined here, and you can call it front towards back here. Okay, so now I know that somewhere in here is where that that feature has to fall. Okay, somewhere in there is where that feature needs to fall. Okay? Now, let's do one thing at a time here. Remember that this area down in here for me, which I'm going to do this right in here. Now I've got my construction here, 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 and here. They're like the purple-like colors, if you can see those colors here. Okay? And so I'm going to go through there, and I am going to then project this point from the isometric side right back to the inclined plane. So I'm projecting then that point from here back. I'm projecting then this point back to the inclined plane. Now notice that on here, that this line, this line, this line, this line, this line are all parallel. So if we find this point right across here, then that is going to be parallel on that plane. Okay, it's going to be parallel on that particular plane. So now what do we need to do here? Okay, so then you got to come over here and say, okay, now what is actually going on here? So then this is coming down. So let me go ahead and darken this thing in so it's easier for you to see. So I'm going to get it up here so it's even easier for you to see. I'm going to bring this over, this down, this over, and then that down to here. Okay, bringing this over to right in here. This thing then goes back until it disappears. So that notch now is shot back on the inclined plane. So I drew it on the isometric and brought it back to the inclined plane. Okay, so that's how you find that particular feature. And then what we're going to do is now we're going to look at some of the other parts. So I'm going to go ahead and in here right now, I'm going to darken in some of the rest of this object. I'm going to zoom out a little bit, again, for ease of visualization. I'm going to go over here and darken then. Do I have the whole thing in? Go ahead and darken then this line here. And I wouldn't suggest doing this until you know exactly what you're going to darken in, but this will help you visualize things. This over to here. Again, this top we can put in. Okay. Now, what are we going to see here? Okay. Well, this notch, this cutout, which is right in here, and this one back in here, the inclined plane, or that horizontal plane, comes and meets the inclined plane, wherever the inclined plane is. So then you just follow this line here until it meets the construction or inclined plane, right there. Then that comes down to this point right here. Okay? So then you're going to do the same thing over here. Well, where does then this incline come over to here and touch this one? It should be directly back here. It should be on that inclined plane, and it should come from right in here. There you have that shown. Well, on the back part of it, it just kind of goes back, okay? It just kind of goes back until it disappears. Okay, so we'll just kind of wait for that one in a minute, and then we'll lay out some more of the side. But you know that it's got to come right here. Let's go ahead and finish it in. You know it's going to come, it's just from that point, I'm just directly over, and it's going to come down to that corner. Okay, and then it's going to go back in this direction until it hides behind that plane right there. Okay, so now, what happens at this point? Okay, well now what we have to do is now we have to lay out this geometry here on the incline. It's pretty much the same thing we've done before. We know where point E is. E's at the very top, okay? And then it's just an arc, so I'm just going to go up here and say, okay, right now at this point, I'm going to put in E. So E is at the very top center. So this thing is, how many blocks? This is 10, so I'm going to count over 1, 2, 3, 4, 5. Here's point E. And at the bottom here, again, I'm going to count over 1. Go it up here a little bit. 1, 2, 3, 4, 5. There's that point there. So again, lightly, I'm just going to put a construction from here over to there, and it should be running parallel with the other lines. If I can get it to... So then, put it in the same color. If I can remember what color it was. Is it this color here? Half colorblind, I can't tell. There we go. So now I'm going to bring this down. Here's my construction there. So now E is here. So then what do we need to find? Well, we need to find then this axis line right in here, which we call DF. Well, you can find that on the outside of the object because it's up from the bottom towards the top. 1. Again, I'm going here. 1, 2, 3, 4, 5, 6, 7. Let me count that again. 1, 2, 3, 4, 5, 6, 7. Okay, so then you know that line has got to be up 7. So then I'm going to, say, okay, where's that axis line going to be? So if I come over here and count up 1, 2, 3, 4, 5, 6, 7, and I bring this across to the very front of the object, where it crosses that incline, right here is going to be that point going back through. I'm going to draw it all the way across here. So where it crosses is defining the center point of an eventual ellipse. And now we have those points labeled over here. We have this one as D, and we have this one as F. Okay, so then this one here becomes, and again, there D is set in 2 and F is in 2, from left towards right and from right towards left. So then this point here becomes D. This point here becomes F. Okay? So now we know that D is eventually going to turn around. So now what happens? Okay? We have also points C and G over here. So we know that C is right here, and that, oops, that's a C, not a G. There's a C right here and a G right there. Make sure I got that right. C back to G. Well, C connects to D and G connects to F. Well, we can go ahead and connect those, because C connects back to D again, G connects back to F. So let's go from C to D, or D to C, and then go from F down to G. So now we know that the top, or the ellipse construction, is going to be in this area right in here. In this area right in here. Okay, well, we know some points here. We know that this point, and we know this point. Okay, so then we can again come up and say, okay, let's go up 2 blocks and find points N and O. Okay, they're 2 blocks down from the top. So again, I'm going to stay on the very outside of the object. I'm going to come down 2 blocks, and I'm going to draw construction all the way across the front of the object. So I'm on the very front of the object, right in here. Here's my total construction box of coming over to here. Where that intersects here, it's convenient, it's on a line. It's going to come back over, and it's going to define which points here. Well, now we have to measure. So we had it located up. Okay, we had it located up this distance. So I came over here. Let's see, I came down 2 from the top. Now I want to shoot this over that distance there. So again, that is, let's say, 1, 2.5 blocks. So let me zoom up on this thing to show you where I'm at. So I came over here and I counted along here and I went down 2. Okay, and I took that all the way from here all the way across, just like we did on this side. So again, I went on the front of the object and I counted down 2, and I went all the way from here till I hit the inclined plane. then I shot this distance back across here. Okay? So here is then the bottom of the ellipse. Okay, we're just going to have the top part of it. Okay? So then so if I counted down 2, I found this mystery point here and a mystery point here. So now I need to find from the axis how far these things over. Well, again, it goes over either from the front, you can shoot it out, or from here. I'm going to actually take it from the front. 1, 2, 3, and let's say half blocks. So now, excuse me, that's on the left-hand side, not the front. So I'm going again from the very left-hand side of the object in 1, 2, 3 and half blocks. So then I'm over here, okay, I'm over at this point, because I remember now, okay, I'm going to come down here. So again, I came down, let me trape this thing around here. So I came down 2, and I moved along here, and I shot this thing all the way to the very front of this construction. Now, from the front of this construction, I'm going to go back 1, 2, 3 and a half blocks, okay? And then you can bring that point back. Now, let's see if I've got this right here. Okay, something is not awry here. There. Let me look at this again, okay? Well, I can measure over 1, see here, 1, 2, 3, that's not correct, okay? Let me get my bearings straight over here. From the front, I go over 1, let me get down here, I'm sorry, 1, 2, 3 and a half. Now I can bring this straight down, parallel, until it hits the point I shot out. So again, I'll go over this again. I'm locating a point right here. And again, if I come back from the right-hand side, 1, 2, 3 and a half blocks, I bring that down. It locates another point right here. Okay, it locates another point right here. Now, does that make any sense? Okay. There's 1, 2, and that doesn't make any sense, okay? Let me do this again, okay, because I think I just messed up. Let's go back over this again. Mistakes make you learn better. So maybe I did do it. I came down 1, 2. I came over 1, 2. It should have been 2 and a half because I'm finding this one here, not this one. This one right in here. So again, remember I come on the very front of the object. I'm coming down 2. So again, on the very front of the object over here. Came down 2, okay, and then I brought this, get over here, then I brought this to where it hit the incline, and I brought it back here, okay, and then instead of counting 3 and a half, I should have counted 2 and a half from the front, because again, I'm getting this distance from right here, 1, it's even more like, yeah, 1, 2 and about a half, okay? So then I'm going to come over here and go, okay, there is now 2 and a half, and I'm going to bring that point parallel with this line down to right in here and find that point over here, and then going back 1, 2 and a half, bringing this parallel down to, let's see here, from the back, 1, 2 and a half, here. Okay, now you can start to basically develop an ellipse. And the more points you bring through here, the more accurate it's going to be. But again, if I draw an ellipse out in here, bring my ellipse over into here, bring it down a little bit, maybe bring it around a little bit, maybe lighten this up here. Okay, so I'm coming here through that point, I'm going to round up, round back down, and round this over to there. Now you can see that, duh, I made a mistake. Okay, I got too happy with my construction here. Okay, and that's why you don't want to. That's why you don't want to rot this stuff in here. So now you're going to bring this over. So now on the incline, we've got the incline plane plotted out. but I sure as heck shouldn't have gone through here and darkened these things in. Okay, that is a mistake, because I know that this point here is on a normal plane, so I can bring that down then, and so I can say, okay, what is the size of this one? And it goes 1. My size of this then is 1, 2, 3, so it's a diameter 6. So then over here I should have gone down 1, 2, 3. Okay. Here's my construction back in here. So it goes 1, 2, 3, 4, 5, 6. Ran down 3 more. It's to here. I got too happy with my construction. Okay, don't make that mistake. So then here is just a normal ellipse construction back in here. And that gray is not much different than the other. So I'm going to put it in red, or a form of red. So getting it over where you can see it again. So again, here is the point on the back. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Here's my ellipse construction on the back. And so then my ellipse over here would go then like this. And then if accurate, this point here, okay, it would just come up over, come down to that point, bringing that point forward, and then all of this would be now removed. This, and that, and that, and that, and that. I don't know why one of you guys in the audience didn't tell me that. Because there's no audience. That's why. You do the same construction then for this hole. Okay, you would do you'd measure out points for the hole, and then you would, let's just do it, I'm going to do it fairly rapidly, okay? So then I want to find these points for the hole. I know the middle point of the hole is right here, okay? And I know this is one back over here. So again, if I come down to my middle point, which is between what? It's between D and E, or D and F, excuse me. Okay, here's then D. Here's F. My middle point then is right here. I'm not going to darken it in. Middle point is there. Okay. And then you'd have to measure, okay, then I'd come up from, so I'm going from the bottom to determine this point R. 1, 2, 3, 4, 5. And then it'll be 4, so I'm going to stay on the front of the object. 1, 2, 3, 4, 5. Okay, I'm going to bring that back towards the incline. Shoot that thing over in here. Okay, so what point does that define? Well, that just defines that line on the plane. So again, if I brought this thing all the way across the plane, it's just showing the line on the plane. Okay, the line on the plane. Well, you know then that that thing is what? It has got to be then, how many far is it from the bottom? Again, 1, 2, 3, 4, 5, 6, 7. Shoots across. Okay, so again, 1, 2, 3, 4, 5, 6, 7. Okay, let me make sure here, because I may be, so here's the center point of it. Now let me redo this thing again. I'm looking at point R. It's 1, 2, 3, 1. Get back up here, Craig. 1, 2, 3, 4, 5. Sorry about that. And it's in 3 from here, or in 1, 2, 3, 4, 5 from the front. So again, I came up 1, 2, 3, 4, 5. I brought it back to the inclined plane. That's from the front. And then I'm going to bring it over from that same point, 1, 2, 3, 4, 5. I'm going to bring it back 1, 2, 3, 4, 5. not 5, but I want to bring it over what? It's not going to be 5 here. It's going to be then, it's going to be back 2, excuse me. So again, I'm going up 1, 2, 3, 4, 5, going back 2, shooting this thing back across. I've got myself lost here. Let me back up again. 1, 2, 3, 4, 5. This goes across to here. Okay, go back 2, bringing this across to here. And I'm doing something wrong here a minute. Okay, see, even everybody makes mistakes here. So I'm trying to find point R. So that's going over 1, 2, 3 instead of 2. So I'm going up 1, 2, 3, 1, 2, 3, 4, 5, and coming in 3. So again, 1, 2, 3, 4, 5. Shooting back to the inclined plane, and then when I count up 1, 2, 3, 4, 5, I'm going back 1, 2, 3, and I'm bringing this back over, and then there is that point right here. Okay? Let's see here. 1, 2, 3. 1, 2, 3, 4, 5. Should be right here. I'm doing something wrong. No, it just comes, I'm sorry, it just comes back up, back over, and it locates right here. I don't know why I'm making this so difficult, okay? Because I've just come up, come over, and it hits that middle point. So again, at 1, 2, 3, 4, 5, 6, 7, which was then 1, 2, 3, 4, 5, 6, 7. Shot this back to here, brought that back over, and there's that middle point. Okay, there's the middle point. Excuse me, I'm going down 5. Boy, I'm really messing up. One more time here, folks. Sorry about this. I'm really confusing you, wasting your time, wasting my time. So I'm coming up 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. I'm coming over then 1, 2, 3, and I'm bringing back a point here. Okay? That point has got to be right here. It's got to be in the middle. So 1, 2, 3, 4, 5. It's still got to be in the middle. 1, 2, 3, 4, 5. Bring it over 3. And then it shoots back until it hits this line. Whoo-wee, it shoots back until it hits, let's see here. 1, 2, 3, 4, 5. Okay, comes back over to here, and then 1, 2, 3, and it goes up to this point. But I don't know why I made that so difficult. Okay, so there's one point down at the bottom. Let's try to make the top one easier. The top one then goes from the bottom 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, from the front. So 9 from the front, and then 1, 2, 3, and I shoot that back. See, I'm shooting it back this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bring it back to here. It hits the incline. Okay, but you got to be on the front of the object. So again, let's drop. This thing is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I come over here, and I'm going to say, okay, it's up 9, so I'm going to grow to the center of the object. So again, I'm bringing this back. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bring it over to the inclined plane. Bringing that back, all the way back, all the way back to the incline here, to where it hits the inclined plane right here. Bringing that across, okay, right into here. Okay, so again, I'm going, let me start down here before I lose you all again. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to have to redo this video, that's for sure. Bring it at the inclined plane, so I'm bringing it back to the very outside of the inclined plane. Over to right here. Shoot at the middle point, so now we have this point established, which I think I labeled on here as P and R. This is point P, this is point R, and then we have point S and O. They're right across the incline, one end. So again, if you find they have to be on the same line as DF, they're one end from the side here. So there's a side, then here becomes a point right in here. Measuring in 1, measuring back in here 1, estimate it. So then if you look in here, here becomes your rhombus or your construction for your ellipse. And again, if you put more points in here, it's going to fall out. But it took me a while to figure this thing out. So again, I'll have to redo this lecture at some point in time. I hope I didn't confuse the heck out of you. I sure confused the heck out of myself. Over to here. Bring it around to here. Again, I'm off a little bit over here. That one probably been a little bit wider there, would have been better. So again, okay, we have point P here, point R here, and then we have points S and O. S and O right there and right there. So again, R is here. Bring it up. So again, I went up to this value of 1, 2, 3, 4, 5. Again, 1, 2, 3, 4, 5. Shot it back over, brought it down to the middle point. There's R. The other one came up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Brought that over the incline, clear over to here, brought that back to the middle point. That gave you these 2 points. That was about a block in and a block in, and then there. Hey, what do you do that for? Okay, my screen went blank for a minute. And this becomes point P, S, O, and R. Okay? So now, when I zoom back out, from this, there you have a construction of this thing minus some of these lines in here. You know, it's going to take a little bit of time. I hope I didn't confuse you too much on this thing. But if you watch the video and take your time like I try to do here, it should fall apart. And I know this is a long video, so I'm going to say over and out, and everybody have a safe day, night, evening, whatever it may be. And we will talk to you at some other time here as I walk over and I turn this recording off. And let's see how long this thing is. It's 1 hour and 32 minutes. Boy, I've gotten long-winded on this.